All right, so these notes are for section 2-3, and we're dealing with functions with this video. We're going to determine when things are and when they are not functions, and then we're going to talk about function notation. All right, so here we have a relation that may or may not be a function. So you have to sort of think about whether this mapping, we call this a mapping, this oval, the numbers on the left are considered the domain, and the numbers on the right oval, are considered the range. And so we have to think about whether or not this mapping of these domain values onto the range values, whether or not that is a function. So we might look at what is f of 0. So if I put a 0 in, what do I get out? Well, 0 gets mapped onto 0, so the input of 0 gives us an output of 0. Okay, and then what about if I have f of -4? That is going to be -5. An input of 5 gives me an output of -5 as well. That's okay. That doesn't make it not a function. What would make this not a function is if one value in the domain mapped onto two different in the range. So this is technically a function. Let's look at this last value, f of 7. Well, the domain does not include 7, right? There is no input in our domain of 7. So you can't, our function is not defined for an input of 7. So the domain only contains 2, 5, -4, and 0. We cannot calculate the function's value at any other value other than those. So this one is not defined. This function is not defined and an input of 7. All right, how about this function? Or I should say this relation until we determine that it is a function. So f of 0, well, that's just 3. And f of -5, that's clearly -3. All right, now here's the problem. If I ask what's f of -4, well, there's two options, and we can't have two options for this to be a function. So this would be considered a relation, but not a function. All right, so we shouldn't even use the function notation f of x. It's really just a relation. We'll sometimes use function notation f of x for something that's not actually a function, because sometimes we don't really know to start with whether the thing is a function or not. So we have one value of the domain, -4, which is mapped to two different values in the range, and this is not this is a problem. So if you think about it, if we were to graph these points, so if we were to graph the point 0, 3 as though it's an ordered pair, and -5, 3, and then we were to map -4, -3, and -4, 1, then those two last sets of points would be vertically above each other. And that is another way of identifying the fact that this is not a function. All right, are the following things functions? The following relations functions. So on the left, we have an ellipse. We'll graph ellipses later this year. And so we have something called the vertical line test, and the vertical line test fails here because the vertical line crossed the relation or the graph at two different spots. And so that tells us this is not a function. So if we have 2 points above each other on a graph, this graph does not represent a function. It's simply referred to as a relation. And then the line on the right, yeah, the vertical line test passes here. It only crosses the vertical line only crosses the graph, the relation, at 1 point. So that is a function on the right. Okay, let's evaluate this. So find f of 0 for me. So f of 0 means what would the y value be for a point whose x is 0. So the x is 0 at this point right here, and so our f of 0 would have to be -4. And then what's f of 3? So f of 3 means the x value is 3. What would the y value be? So at 3, we're here, right? The x value of 3, the y coordinate seems to be 2. And then at f of -1, find that. F of -1, we're at -1. We go down and we see that the y coordinate is -6. And then lastly, f of 5. So we go 1, 2, 3, 4, 5, and we go up, and we see that we get a y coordinate of 6. All right, so in the last slide, we had the function represented by a graph. Here we have functions represented in other ways. So one is as an expression, and the other two are as ordered pairs. All right, so what is f of 4? That means I go to the function f, which is this one, and I plug a 4 in for x. So plug a 4 in for x. What do you get? Get 28. All right, so 4 squared is 16. 16 times 2 is 32, minus 4, 28. All right, what is g of -3? So that means if your x is -3, what would the corresponding y be? And so we can see here that this point has an x value of -3, so we should have a y value of 4. All right, and then the last one, the function h of -1. Well, that's a problem because we have -1 gives us an output of -7, but it also gives us an output of 2. So this one is not a function. H is a relation, but not a function if one input cannot have 2 outputs. Essentially, we wouldn't know what to answer this question, right? All right, so the notation f of x. It looks like f times x, but it does not mean that. It is not f times x. It's a function f, and the variable that we use in the function's expression is x. So instead, f of x represents a y value of the function that corresponds to an indicated x value. So in the previous example, we had f of x is equal to 2x squared minus 4, and we asked what f of 4 was. So f of 4 represents the value of the function when the function is evaluated at an x value of 4. Now that's a lot to write. So instead we just say, please find f of 4 rather than find the y value of the function when the function is evaluated at an x value of 4. It's just too wordy. So instead we say f of 4 equals what? And so f of 4 would simply equal, put a 4 in, we saw it in the previous slide, is 28. All right, so let's practice some of these. Why don't you pause this video and then try these. I'm giving you 3 different functions, f of x, g of x, h of x. So the letter in front tells you what function to go to, and you plug that value in the parentheses as the x value or as the input. So pause the video and find all 8 of these. All right, so number 1, f of 0, we simply put a 0 in for x, we get -4. Number 2, g of 3, go to the function g, put a 3 in for x, we get 6. H of -1, put a -1 in for x value, go to the function h, and plug in, instead of these x's, plug in -1, and we get 0. Okay, the -1 here, the negative would go away in this squaring, so it would be -1, and then the -1 in here would cancel this negative and make it positive. So that's why we got 0. All right, f of 5. All right, that's -19. Number 5, f of f of a. Now this time, the last four we all had as a result, the results were all numbers. Here we're putting in, instead of putting in numbers for the x, we're putting in variables. So we're going to get expressions out. So put in a, go to f of x, go to that function, take out the x and put in an a. What do you get? All right, you should have negative 3a minus 4. Go to G and plug in 3x. What do you get? You get 3x plus 3. And go to H, put in negative 2x. You get negative 4x squared plus 2x. And finally, what is f of x plus 5? So we're going to put in x plus 5 into this x here. We'll distribute that negative 3 to both things and simplify, and we end up with negative 3x minus 19. All right, so part of what we're going to be interested in when we deal with functions is the domain and the range. So the domain is the possible x values that all the points could take on, or the lower to upper, like what's the highest and lowest value that x's can be. And then for the range, same thing, but for the y. So if we look at this first one, it's an ellipse. And so what's the lowest value? That looks like what, negative 9. Highest value, it looks to be 11. That's the domain. And for the range, it looks like we go from negative 7 up to positive 7. All right, and those are inclusive, so we're going to use brackets instead of square brackets rather than parentheses there. And then on this one, we should assume that since this line kind of goes off to the edge of the graph, that there's an arrow there and there's an arrow there. It didn't stop somewhere in the middle, so it went all the way to the edge. When it goes all the way to the edge, you should assume that it kind of continues without end. So what would be the possible y values, the x values for the domain and the y values for the range? All right, so those are positive and negative infinities for both. They go on forever in both directions, up and down. All right, for h, what's the domain? Well, the domain is simply the x values. So there's only 3 of them. And the range, there's only 3 of them. So we simply list those separately. Okay, 3 individual values. And similarly, for the last one, there's 4 values in the domain and 4 values in the range. Now, sometimes we could have repeats, and if we have repeats, we don't bother repeating them. But in this case, there were 4 distinct values in the domain and 4 distinct values in the range. All right, so let's practice some more function notation. We're given 2 functions, f of x and g of x, and find f of negative 3. So pause the video and figure that out, and then let's see how you did. All right, so we plug in a negative 3 into the x squared, and then we simply simplify. And so we get 13. All right, next one. Find f of d. So again, we're not putting a number in, so we're going to get, more than likely, we're going to get an expression out. So we plug a d in for x, and then we simplify. It's really just negative d squared minus 6d plus 4. All right, C. So find g of 2. So we simply take the x out of the function g of x and plug a 2 in and simply simplify that to 7. All right, D. So find g of 3a. All right, so we simply go to G and we plug, instead of x, we plug in 3a and then we simplify. So this one, again, is not going to have a number as an answer. It's going to have an expression. So 9a plus 1. All right, E. There are 2 e's. So first E is g of 2x plus 1. All right, so we're simply going to take out the x and put in the binomial. This time we just got to make sure we're distributing properly. We get 6x plus 3 plus 1, so 6x plus 4. All right, and the second e. I snuck an extra one in there and didn't bother to renumber or re-letter all these examples, so I just stuck another one in and called it E2. All right, f of x minus 1. If you want to pause the video and figure out that one. All right, so we're plugging in the x minus 1. We got to FOIL that one, that first binomial. This has got to get FOILed. And the negative 6 gets distributed here. And so we FOIL that out. I didn't bother distributing the negative yet. I'll do that in the next step. Here I distributed the negative 6 to the x and to the negative 1. And now I'm ready to just distribute the negative, and now I want to combine like terms. And so I get negative x squared minus 4x plus 9. And that's it. We're just going to leave that one as an expression. All right, f. So we want to write this in using function notation. So this is the standard equation of a line. And so what we want to do is, if we're going to use function notation, we have to solve the equation for y. And then we just replace the y with f of x, because f of x and y are kind of the same thing. If we use just y, then it may or may not be a function. But if we use f of x, that means the thing is a function. All right, so let's rewrite this and solve it for y. Think of it as a literal equation that we're solving for y. So first thing we do is we move the 2x to the other side, and then we're going to divide through by negative 5. All right, and then instead of y, we want to replace it y with f of x. So we have f of x equals 2/5 x minus 2. And finally, we want to know what f of 3 is. So we plug a 3 in for x, and then we just simplify and get negative 4/5. All right, let's try g. So g is an equation. Again, we want to solve this one for y. Pretty straightforward. We just move the x squared to the other side. Now we have a quadratic on the right-hand side. But we want to replace the y with f of x. You want to use the actual notation. Okay. And then again, we're looking for f of 3. So plug that in. We square the 3, we do 4 times 3, and then we subtract 2, so we get 19. All right, and now h. So if you remember, we did this, we graphed this function back in section 2.1. And if you remember, we knew that the square root of y minus 1, the result on the right-hand side, would always have to be positive, or, well, it couldn't be negative. It could be 0, I guess, but it cannot be negative. So that tells us x cannot be negative, and that's kind of important because what we're probably going to do here is square both sides. And so we've kind of hidden the fact that we have a restriction at the beginning of this problem when we square both sides. All right, and then we simply set it equal to y. By moving 1 over, so we get y equals x squared plus 1, and then we write it using function notation. Now, we have to put some limits here because of the way the original problem was written, and we knew that x could not be negative. So we say that's the function, but we have to limit the domain here. We have to say where x must be greater than or equal to 0. And if you remember the graph, it looked like half of a parabola. Now, if we didn't put that limitation of x being greater than 0, then we would have the other half as well, and that wouldn't be possible for this original problem, because then x would be negative, and x can't be negative because we can't have the right-hand side be negative. So we would eliminate that right side. Okay, finally, what is f of 3? We simply put a 3 in for x. We get 10. Okay. Let's move on to this last part of our notes then. we have this what's called a piecewise graph. So it's made up of different graphs. This one's sort of continuous. Now on this end, we're going to assume it goes on forever, kind of continues in that direction forever. This one stops in the middle, so we're going to assume it's just a point at the end right there. I guess that would be at 16, -7. This graph just ends on this side. The other side, it goes off the edge, so we should assume that there's an arrow there. Okay, we're asked to describe where the under what intervals this piecewise function, we call it, is increasing. So as we go from left to right, is it increasing? So you can see, like if I look at a point over here, if I go just to the right of that point and just to the left of that point, to the right it's above, to the left it's below. So that means as I'm going from left to right across to this in the x direction, this function is increasing. So it's increasing from -infinity, because remember this goes on forever, so -infinity up to -3. Now we call these out in terms of the x value, not the y value. So we wouldn't say it goes all the way up to -1. We go over to -3 because -3 is the x x value. So all these are determined according to the x values. So this is not a ordered pair, but this is an interval. It's from -infinity up to 3. And the point itself is not increasing at that point, right? At that point, it's below us on the left and also below us on the right. So on the right, it seems to be decreasing. On the left, it seems to be increasing. So so we don't include we do a square bracket here. All right, and so where else in this graph are we increasing? So you can see from 6 up to 10, we're increasing. Careful, this part is flat here, right? So it looks like it's a parabola, but that parabola stops here, and then it goes horizontal over to here. And then it looks like it's also increasing on this range, right? Up here, going up. So from 11 over to 13. Again, all these intervals are given based on their x values. All right. Under what intervals is this function decreasing? And again, we use parentheses for all of these. We don't ever use square brackets for these. All right, so it's from -3, which is this x value, right? -3 all the way over to 6. It is decreasing. Is it decreasing anywhere else? Yeah, it's decreasing from 13 down now, not forever, not to positive infinity, but stops at an x value of 16. All right, and now when is it constant? All right, that was just that little spot up here between 10 and 11. It is constant. So at that point 10, for example, it's not constant. It's not increasing. On the left, it's increasing, and on the right, it's constant. But at that point, it's like a changeover point, and we don't include it. So that's, again, why all of these have parentheses. None of them have square brackets. All right, and then let's use this same graph to answer some other questions. Use the graph of f of x above to find the following. So find f of 0. So remember f of 0 for this whole function f of x, where is the x value 0? So there's only one x value of 0, it's right here. And so what is the y coordinate? So the y coordinate's -2, okay? So that's basically what it's saying. It's saying find the y value for this function when the x input is 0. That's what f of 0 is asking you to do. All right, what's f of 10? So f of 10 would be here. It is also -2. All right, f of 12. All right, f of 12 is up here, right? The x coordinate of 12 is up here. So that has a value of 1. All right, f of -8. So we have -5, -6, -7, -8, and we go down and read off its y coordinate. So that is -6. All right, f of 1. All right, so f of 1 is right here. You don't have to guesstimate. You can look at the slope of this line and you should be able to figure that out. Why don't you pause the video for a second and see if you can figure out what that y coordinate would be of that point. All right, so that point is, if you look at the slope of this line, it's a slope of 1/3. So when I know I go over 1, I'm going down 1/3. So how many below is that? That's 3/3, 6/3, and one more is 7/3. So -7/3 would be that point. And then the last one, f of 15. So that looks to be right here, right? F of 15 should be -2. All right, now we're switching it around. Instead of asking, giving you the x value and asking for the y value, now we're switching it around. We're giving you what f of x is. We're giving you the y value. You've got to tell us what the x is that corresponds. So we look for all the points on the function that have y values of 2. So here is y equals 2. And so it looks like to be only one point that has a y coordinate of 2, and that x value in this case is 13. All right, what about the next one? F of x is equal to -7. So we want to think about what points have y coordinates of -7. All right, so it's down here, and it looks like we have 2 of them. We just catch this one here, assuming there's a point at the end of that one right there. So it looks like we have 2 of them. We have -9, which is down here, and we have -9, which is the x coordinate. That's what we're looking for, and 16, which is the x coordinate for that point. All right, and then the last one, f of x equals -2. So that's where -2 is. So we have a number of them here, and we also have a range. So we got to use an interval. We have a couple of different individual values, but we also have an interval. And so what would those look like? All right, so we have one at -4. We have an x coordinate of 0. We have a range from 10 to 11. In this case, it's actually, the y coordinate is actually equal to 10 there. Sorry, the x coordinate is equal to 10 there. So we would use square brackets in these cases. And 11 here, we would use a square bracket because it's actually, the x coordinate is 11 at that point, and it has a y coordinate of -2. So no parentheses there, brackets. And then the last point here looks to be about 15. All right, so this is your homework. Remember, multiples of 3 is what that times 3 equals, and that is due next class.